Chapter 6 is about polynomial functions, and the first section, 6.1, goes over adding and subtracting polynomial expressions and functions. Now before we get into how to add and subtract them, I'd like to first just talk about what is a polynomial. Now consider the function f of x equals 3x cubed plus 2x squared minus 5x minus 3. This is an example of what's called a polynomial function. Now the thing that makes it a polynomial is that all the powers on the variables are positive whole numbers. So you have x cubed, x squared, x to the first, and I guess you could really think of this as being x to the 0. But the exponents are whole numbers. 3, 2, 1, even 0 would be a whole number. So anything that has positive or whole numbered exponents on the variables and has several terms in it would be called a polynomial. Now the number of the terms in a polynomial are separated by the addition and really the subtraction symbols. So if you look at this particular example, there's 1, 2, 3, 4 terms. Okay, so there's 4 terms. And you want to think of, again, terms are separated by addition and subtraction, although when it's subtraction, you really want to think of it as adding a negative, so the negative is really part of the term. So in this case, the terms would be 3x cubed and 2x squared and negative 5x, because you're really adding a negative 5x, and negative 3. And the word coefficients mean the numbers that are multiplied in front of the variable each time. So in our case, the coefficients would be the 3, the 2, the negative 5, and the negative 3. So those are called coefficients. So the coefficients would be 3, 2, negative 5, and negative 3. And another word that you have to be familiar with is the degree of a polynomial. Now the degree is the highest exponent. So in this case, the highest exponent would be 3. So this would be an example of degree 3 in this case. Now I should point out that some polynomials have more than one variable in them, and so you'd have to add the powers of the two variables together to see what the degree would be in that case. I'll give an example of that in just a minute. Now I'd like to go through just a few examples of some different kinds of polynomials with various different degrees. I'm going to start out with degree 0. Now degree 0 means that the function would just be a constant. So f of x equals some number. Like I'll say f of x equals 4. That would be an example of a degree 0 polynomial. So that's fairly simple. The graph of that would be a horizontal line, because that's the same as like y equals 4. Alright, so let's go up by 1 degree now, and we'll talk about a degree 1 polynomial. That means the highest power on the x would be 1. So it would be f of x equals like 6x plus 2. Now notice that's really of the form y equals mx plus b. So you're going to have a graph that's a straight line. Now depending on the slope, it could be positive or negative. In this case, the slope would be 6, so it's positive, so it would be an increasing line. But in another example, the slope could be negative. So in general, the graph could be a line that slanted up or down. Alright, so let's now go up to the next degree, degree 2. So degree 2 means the highest exponent on the x would be a 2. So it would be of the form f of x equals, and then you'd have some number times x squared, like 2x squared minus 3x plus 1. This would be called a degree 2 polynomial. That's often called quadratic as well. So there are different names for some of these. I'll go over those in just a minute. But the graph for a degree 2 would be a parabola, which is a U-shaped graph, and sometimes it would open up and sometimes down. And then a degree 3 polynomial would have an x to the third power as its highest degree. So it would be f of x equals like x cubed minus 2x squared plus 3x plus 5 would be an example. And the graphs for those can look a few different ways. They can sometimes be increasing like this, or they can be decreasing, or they can even go, up and down a little bit like this. Okay, but it would be one of those types of shapes of graph. Now, in general, when we have degree 0, let's look at some names for these. A degree 0 would be called a constant function. Okay, so I'll write that right below here. That's a constant function. And a degree 1 is a linear function. And we've actually spent quite a bit of time talking about those kind of functions already. And a degree 2 is called a quadratic function. And degree 3 would be called a cubic function. And I could keep going. I could do degree 4 and degree 5, but these are some of the most commonly occurring types of polynomials, so I thought I'd go over these particular ones in detail and tell you what the different names for those are. Now, sometimes we also refer to polynomials with regard to how many terms they have. So, if they only have one term, we'd call that a monomial. Think of mono as meaning one. So monomial means one term. Okay, and if they have two terms, then we'll call it a binomial. Bi meaning two. And remember, addition and subtraction are what separate out terms. So that's how you could determine how many terms you have. And if you had 3 terms, as you might guess, what prefix means 3? Tri. So if it was 3 terms, you'd call it a trinomial. So just to give you a couple of examples of some of these, like a monomial would be something like 6x squared y. Because since there aren't any addition or subtraction present there, everything is multiplied together. That's one single term. And something with 2 terms would be something like 3x plus 5y. Notice that the plus sign here separates this into 2 separate terms, so to be a binomial. And a trinomial would be, an example of that would be like 3x squared plus 6x minus 2. Notice you have an addition here and a subtraction here, so that's separating that into 3 separate terms. That last term would be negative 2 because it's really adding a negative 2. And now let me just look at this first example of this monomial up here, 6x squared y. Remember I was saying before that in those cases when you want to find the degree, since the x and the y both occur in the same term here, you would have to add the 2 powers together. So 2 plus 1 would be degree 3. So that would really be degree 3. Now in the second case, you have 2 separate terms. The highest power in the first one is a 1, and the highest power in the second one is a 1. So that would be just degree 1. So when you find the degree, you really find the degree of the highest term. And in this last case, it would be degree 2, because the first term has a 2 in it, whereas the second one only has a 1, and the third one doesn't have any variable at all. Okay, so just to check that you understand that, let's look at this example. And the question is, what is the degree of this particular polynomial? So the way you'd answer that would be, first of all, you'd look at each of the separate terms. Now, how many terms are there? There's 3 terms here, because again, the addition and the subtraction separates the terms. So if we look at it term by term, since these terms have more than one variable in them, you'd have to add the exponents together to figure out the degree for each one. So in the first case, the degree would be 2 plus 3. 2 plus 3 would be 5. Okay, I'll just write that underneath. And in the second case, we'd add, really the exponent on the x would be a 1 implied. So 1 plus 2 would be 3. And then in this last term, you would have 2 plus 2, which would be 4. And the degree of the overall polynomial is the highest of those 3 answers. So in this case, the degree would be 5, because you'd have to take the highest degreed term to find the degree of an overall polynomial. Next, I'd like to go over how to add and subtract polynomials. Now, let's start with adding polynomials. Now, when we add 2 polynomials, as we see in this first example up here, we have a one polynomial that's in parentheses being added to a second polynomial that's inside parentheses. This is really simple. All we need to do is combine the like terms. Now, like terms have to have the same variable and the same exponent on that variable. So the variable parts of the terms have to be identical. So for example, 6x squared and a negative 4x squared are like terms. So we can combine them by just adding the coefficients. 6 plus negative 4 would be positive 2. So we would have 2x squared for that part. And then we'll do the same thing with the 2xy and the negative 9xy. Now 2 plus negative 9 would be negative 7. So we'd have negative 7, which we can just write in as minus 7xy. And then we'll do the same thing with the y squareds. We have a negative 1y squared. Remember that coefficient is a 1 implied. And a negative 3y squared. So negative 1 plus negative 3 would be negative 4y squared. So notice when you're combining the like terms, you don't change the variable part. You're just adding the coefficients to combine them. And that would be as far as you could go, because of these 3 terms in the answer, none of those are like terms. Now, subtracting polynomials is similar. However, you have to be a little careful here. You have a minus sign followed by a set of parentheses. Okay, and whenever you have that situation, the best thing to do is think of that as being a negative 1 in front of those parentheses. And I'm going to circle it, negative 1. And that negative 1 has to get distributed through everything in that second set of parentheses. Alright, now this first set of parentheses really just has a positive 1 in front of it, implied to be there. And if you multiply everything by positive 1, of course nothing changes. So that first polynomial is just going to stay the same, 6x squared plus 3x minus 1. But then in the second one, you're going to have negative 1 times 4x squared, so that's minus 4x squared. And then a negative 1 times a negative 8x would be a positive 8x. And then negative 1 times positive 3 would be negative 3, so I'll write minus 3. So that's the really important part to remember when you're subtracting polynomials, is you really have to distribute that negative 1 through that second polynomial first. Now once you do that, then you can just combine the like terms as we did before. So 6x squared minus 4x squared would be 2x squared. And positive 3x and positive 8x, when we combine those, we'll get plus 11x. and then -1 and a -3. When we add those together, we get -4, so it's going to be -4. And that'd be our answer. Now, adding or subtracting functions is really the same as adding and subtracting polynomial expressions. You just have to understand the notation. So when you see f plus g in parentheses of x, that really just means f of x plus g of x. So that's just adding the two functions together. And when you see the notation f minus g in parentheses of x, that's f of x minus g of x. So there you're just going to be subtracting the two functions. So let's look at an example. So let's suppose we had f of x equaling 2x cubed minus 4x plus 1, and g of x equaling negative 3x squared plus 5x minus 3. And let's say the problem said to find f plus g of x. So f plus g of x is just going to be f of x plus g of x. So we're just going to add the two functions together, and again, to do that we just combine the like terms. So we would just have 2x cubed minus 4x plus 1 being added to a negative 3x squared plus 5x minus 3, and we'll just combine our like terms. Now, usually you want to start with the highest powered term first and put the answer in what's called descending order. And so you'd have 2x cubed. Now there aren't any other x cubes in the problem, so we'll just leave that one as it is. And then we have negative 3x squared, and there aren't any other x squareds either, so nothing to combine that with. And then for x to the first powers, we have a negative 4x and a positive 5x. That'll give us plus 1x, and it's simpler just to write plus x. The coefficient of 1 is implied anyway. And then we have a positive 1 and a negative 3, so 1 minus 3 would be a negative 2, so we'll write minus 2. And that would be our answer, and that's in, again, descending order, meaning the highest power is first, and then it works its way down. And that's generally how you'd like to write your answers. Okay, now let's try f minus g of x. Now that would be f of x minus g of x. So that's going to equal 2x cubed minus 4x plus 1 minus g of x, which is negative 3x squared plus 5x minus 3. And it's important to put that set of parentheses there, because remember, that really means we have to distribute the negative 1 through that second one. And so that will give us 2x cubed minus 4x plus 1. A negative times a negative is a positive 3x squared. And then we'll have minus 5x and then plus 3. And then we'll just combine our like terms. So again, the highest powered one is 2x cubed, and there's nothing to combine that with, so just 2x cubed. And then working our way down, we'd have a plus 3x squared, and nothing to combine that with either. And then we have a minus 4x and a minus 5x, which we can combine into minus 9x. And then a plus 1 and a plus 3, which would be plus 4. And that would be our answer. Now sometimes you might see an example where you actually have a specific x value inside parentheses here rather than just the variable x. And you would do that in a similar way. So f minus g of negative 1 is f of negative 1 minus g of negative 1. And so you'd find f of negative 1 by substituting the negative 1 in for the x in the function f, and you'd find g of negative 1 by substituting the negative 1 in for the x in the function g. So we'd have to do those separately. So f of negative 1 is, we just do each one of those as a separate problem. F of negative 1 would be 2 times negative 1 cubed minus 4 times negative 1 plus 1, which would be 2 times negative 1, because negative 1 cubed equals negative 1, plus 4 plus 1. So that's negative 2 plus 4 plus 1. That comes out to be 3. And then g of negative 1 would be negative 3 times negative 1 squared plus 5 times negative 1 minus 3, which would be negative 3 times 1, because negative 1 squared equals positive 1, minus 5 minus 3. So you have negative 3 minus 5 minus 3, which would be negative 11. So coming back up to my main problem here and plugging those answers in, remember we wanted to do f of negative 1 minus g of negative 1. And we just found that f of negative 1 is 3. So we want to do 3 minus, and then g of negative 1 is negative 11. And subtracting a negative 11 is the same as adding 11. So this will be the same as 3 plus 11. So the final answer would be 14. Okay, I'd like to finish this lesson up with an application. And this one deals with the annual U.S. consumption of milk and soft drinks in gallons per person T years after 1950. And we're given two different models, one for milk. So this first equation models the consumption of milk, and the second equation models the consumption of soft drinks. And part A says find m minus s of t. Now remember, m minus s of t would be m of t minus s of t. So we just want to take the two functions and subtract them. So it's going to be negative 0.27t plus 35.54 minus 0.82t plus 8.96. Now remember, the negative 1 has to get distributed through this second one. So that's going to make that come out to be negative 0.27t plus 35.54 minus 0.82t minus 8.96. And then we just want to combine our like terms. And so when we combine our like terms, we combine negative 0.27t and negative 0.82t. We get negative 1.09t. And then when we combine the two constant terms, 35.54 minus 8.96, we get 26.58. So it's going to be plus 26.58. Now the second part of the question asks us to find m minus s of 60. Now remember, 60 means 60 years after 1950. So that's really corresponding to the year 2010. And so to do this, we can just take our previous answer and plug 60 in for time. So we would have negative 1.09 times 60 plus 26.58. And that comes out to equal negative 65.4 plus 26.58, which equals negative 38.82. Now, as far as interpreting this, remember this is the milk consumption minus the soft drink consumption. And since this came out to be a negative number, that's telling us that the soft drink consumption was the bigger number, because the bigger number must have got subtracted from the smaller number to give us a negative answer. So it's really telling us that the average person drank about 39 gallons more soft drink in 2010 than they did milk.